A circle question that made me scramble my brain a little bit too much. Let me show you how it's done. The first part of this is fairly straightforward. You get given the equation of a circle and all you have to do is complete the square for both x and y. If you don't know how, you simply bring all the x components and y components next to each other. So x squared minus 10x and then y squared minus 8x. Then you write x minus 10 divided by 2 and then all squared. Whenever you do this, you will have an excess, and the reason for it is because you're trying to write x minus 10x only, but then you're going to have an excess due to the 5 squared, which needs to be taken account for. That excess, obviously, is 25, which means you need to minus it, and then you'll be good to go. Do the same thing for the y, and you'll get x minus 5 squared plus y minus 4 squared minus 9 is equal to 0. From the equation of a circle, you can tell that the x-coordinate of the center is going to be when x minus 5 is equal to 0. So x is equal to 5, and then for y it will be 4. Also, the radius will just be the 9 square rooted, i.e. 3. And in terms of the dimensions, it makes sense because this circle is shown into the positive quadrant, so that's fine. Okay, for the actual hard part. Whenever you have shortest distance between the line and the circle, it is referring to the line which hits the circle at the normal and passes through the other line, like I have drawn here. And when a line passes through a circle at the normal, it will also pass through the center. So the normal gradient, so for the normal gradient, just do minus 1 over the gradient of this line here, which in this case was minus 1 over 2, meaning the perpendicular gradient is 1 divided by minus 1 over 2, i.e. 2 in this case. And to get the c-intercept, use the coordinates of the center of the circle. So this equation that I found by solving it can then be inserted into the circle equation like here, giving you a quadratic in terms of x's only. Solving this quadratic will give you the x-coordinates where the perpendicular line and the circle meet. This will be 2 points, but you only need one of them, the 3.658. So then find the y-coordinates as well by inserting it into the equation of the line, and just do a small sanity check that the dimensions make sense. The x is 3.658, that makes sense, and the y is 1.3167, which is under the center of the circle, so we're good. Now that you have the coordinates of your 2 points, just use the length of a line equation and plug your numbers in, giving you 5.5 roughly. There are multiple other ways to do this. You can also just figure out the distance between the point of intersection of the perpendicular line and then also the center of the circle line. And then afterwards you can just minus the radius of the circle. There are multiple ways of doing this. Just use the one that you think makes the most sense for you.